All right, on today's episode of Python Papi, we're back inside our TensorFlow course, and we're still doing our malaria functional API module. Let's have a look at what we went over today. Now, yesterday I left it on a kind of shaky note because I did have some errors in my code that I wasn't sure why it was being thrown. Today was I didn't take hardly any notes today. Today was a day of understanding and debugging, so we did that all morning plus some math. But yeah, let's go over what we have right now. So let me start from the top. So if you remember, this is our model information here. All of this here plus the dense layers here that are commented out. They're commented out for a reason, but the dense layers plus our cob layers is our all of our model information. We learned that the cob information and the max pooling information is our extraction data, meaning this is the data that extracts information from the images, and the dense layers are actually what reads that information, and it brings back classifications for us. It classifies that information as parasitized or unparasitized. So we learned that if we commented out the dense layer information here, as you can see, it's commented out, and we just use the comd and the max pooling layers, we could just get the extraction information, and we can run it just like that by itself as an extractor. So this will be all of our extraction information. So we actually did that. So let's go ahead and have a look at that now so we can see where that is. Okay, you can see here we have our extraction information. This is this here. This is all of our COV 2D information and our max pooling 2D information without the classifying information of the dense layers. So yeah, and you can see we made our max pool here, our output. So all of this information gets outputted here to this to this max pool 2D, and it gives us our output there. And you can see we have an output of none 54 54. It keeps moving. I'm trying to hold it steady for you. It keeps moving. Okay, you can see here we have an output of none 54 54 16. So that's a accumulation of all of this information here. All of this extraction data is output into this here, the none 54 54 16. And all of this will be considered our extraction data. And together with the dense layer, dense layers would be our classifying information. We would get a whole model structure. As you recall, I did run that yesterday. We came back with about 46 million parameters and I think 2,000 non-trainable parameters. So yeah, that's as a whole, that's what we would have. But as you can see now, our parameters are about 1,136. We have total parameters, trainable parameters of 1,092 and non-trainable of 44. So yeah, that's just from the extraction data. That's why the number is so low. So remember, if we were running the extraction data with the classifying data, we would come back with 46 million parameters and about 2,000 non-trainable parameters. Now that wasn't the hiccup part. So we had this down pat yesterday. So what we wanted to do yesterday, what I got hung up on, I couldn't understand, but now I finally have it down pat. We wanted to take this extraction data and condense it down into one simple line of code or one simple function that we can run alongside with our classifying data and bring back the whole entire model. So I actually figured that out finally, and I rewrote that all the way down here just to separate it so we can have some separation between the two. So as you can see, that's what we have here. We have our x equals feature extractor model funct input. So what this represents is this is all of our conv 2D information. This is all of this information here compact into this feature extractor model here. So this is everything here, all of this, all of the con D, the max pool, and all of that. And it should be an output of 54, 54, 16 if we've done everything right. So that's all that goes into here. And then we have our classifying information as usual. And then we have our output, funct output equals dense layer 1 activation sigmoid. So just to go a recap of everything, this represents all of our extractor information. So instead of having to write out all of the COV Ds 2, max pooling 2, batch normalization, all of that got fitted into this one function here, and then we ran it alongside our classifying information. Now I went ahead and did it already just to give you guys a look at what would happen if we did run it and see if we can bring back the entire model, which we did. So as you can see here, we have our feature extractor. You can see here the numbers match up. We have our 54, 54, 16. So this represents all of our feature extraction data here that I showed you with the COV-D, the max pooling and all that stuff represented. All that stuff, it got condensed down into this one function here, the max, not the max, with the X feature extractor model. And that's what this represents here. And then we have all of our classifying information here as usual. and let's see if we can bring back if we brought back the entire model, which we did. So you can see here we have our 46 million total parameters, 46 million and change in trainable parameters, and then 2,244 non-trainable parameters. So that means this is representing our entire model. So with our x equals feature extractor and all of our classified information, the flattening, the dense layers, we brought back our entire model without having to type out the COV 2Ds and the max pooling. So all of that got condensed down into this one function here that we were able to run alongside of our classifying information to bring back our entire model. Now, so I know it sounds a little confusing to you. It was a little confusing to me at first also, but I did get everything down pat and everything is working smoothly. Like I said, I didn't do any coding this morning. Everything was more of understanding and debugging, and it took the whole morning to finally grasp everything to see what was going on. But it's finally moving forward. So yeah, with that being said, we will pick up tomorrow. Hopefully we can get back to coding and diving into new things, and I will keep you guys posted every step of the way. But for now, this is the Python Papi. You guys stay Gucci.